Recording. Okay, so this video we are going to discuss the derivation of magnetic field due to a finite wire. NCERT has not given this derivation, but it's an important application of Biot-Savart law, so we are going to see it. So let's start our derivation. We will consider a finite wire. So finite wire is having current I. Okay, so from this wire, let's say we are going at distance d along its axis, and at that point we need the value of magnetic field. Oh my god, just a minute again, which is this one. I have added chroma key, right? That's why it's not coming out. Filters, delete the filters, and voila, we got it. Okay, so this is a finite wire, and on at this point at distance d from the wire we need the value of magnetic field. Simple derivation. So what we're gonna do is know that from this point we are going perpendicular y distance. We are going at a distance y, and here we will take an element dy. Okay, so here we have taken element dy, and if you join it from this point, the lower end, and then it will make angle theta. If you connect it with the upper end, extra angle will be how much? D theta. Okay, now perpendicular distance is d, this distance is y, and let's say the distance from here element to our point is r. Clear? Okay, so we can say that dB, using Biot-Savart law, dB will become how much? Mu naught I dl. Okay, there is a sine theta in the formula. If you remember, there comes a sine theta, so mu naught I dl sine theta upon 4 pi r square. Okay, everyone remembers this is directly from the Biot-Savart law. Now see, this theta, this sine theta, this is the angle between what? It is the angle between dl vector and r vector. So if I see the diagram very clearly, this is my dl vector along this line, this is the dl vector along this line, and this is my r vector. From that dl I will go to that r point, so this is my r vector. Upward dl vector along this line, along the hypotenuse, that is r vector. So this angle will be the theta. Got it? This angle here, this theta different, this theta is totally different. Here in this sine theta, this angle will be angle between dl vector and r vector. So we are seeing that angle dl vector r vector angle will be how much? Suppose this is theta, so this one will be 90 minus theta. So this is theta, this is 90 degrees, so this is 90 minus theta, so that one will be how much? 90 plus theta. Clear? Okay, so that angle is 90 plus theta. Okay, now simplifying this dB, you will get mu naught I dl sine 90 plus theta, that will become cos theta. Sine 90 plus theta will become cos theta upon 4 pi r square. Okay, now let's see the value of cos theta, or r square. We can convert r square. So d is constant, so in that term we will try to convert all the whatever parameters are there, we will try to convert in terms of d, because that is a constant. So if I define cos theta from this triangle, cos theta will be how much? D by r. So r will be how much? R will be d by cos theta. Okay, okay, this one we can use. Next point we have here dl. dl is the length of the current element. So we have gone at y distance, and what length we have taken? dy. Okay, so dl length we have gone, that we have taken dy. So we can say that our dl is nothing but dy. Okay, so this dl is dy. Now if it is dy, so we need the things in terms of what? Dy only. Okay, so if I have here, if I relate y by d, so y by d will be how much? Tan theta. So y will be d tan theta. So on differentiating it, dy will become how much? D tan theta differentiation is sec square theta d theta. Okay, so dy also we can get. Now putting all these values, so dy and r value in this our db. So db will become mu naught I. dl was how much? dl was dy, and dy is d sec square theta d theta. Okay, that is dl. Now cos theta is there, so we'll get cos theta also, divided by 4 pi r square. So 4 pi r square is from this equation d square, and it will again go cos square theta, so it will become cos cube theta. Okay, so this is our dB, elemental form of magnetic field. Now further simplifying it, you will get mu naught I, d square will get cancelled with d upon 4 pi d, and sec square theta cos cube theta, it will become cos theta and d theta. Okay, so that is our elemental field. So from here, if you need the total magnetic field, what we can do? So if we need the total magnetic field, so we can simply integrate this elemental form. So total magnetic field B will become integral of dB. So let's integrate this dB. Mu naught I upon 4 pi d, mu naught I over 4 pi d into cos theta d theta. So now let's see the limit. Limit here is of angle. D theta is the variable, so it is of the angle. So if you connect this lower end, if you connect this lower end, it will make, let's say, beta angle, and if you go upward, it will make alpha angle. So limit will be, downward is beta and upward is alpha. See, downward when you are going, no, it will be negative, so minus beta. Upward you are going, you are taking positive, so alpha, because angles are in different directions. So one clockwise, anti-clockwise. So anti-clockwise you are taking negative beta, clockwise you are taking positive alpha. So here mu naught I over 4 pi d will be out of the integration. Cos theta will become sin theta, and then minus beta to alpha. So magnetic field formula will come out to be how much? Mu naught I over 4 pi d in bracket sin alpha minus sine of minus beta. So minus will come out, so it will become sin alpha plus sin beta. Okay, so you can easily go through these formulas to build the concept well. Only integration is important. There is very less chance that board is going to ask this question. NCERT have not mentioned this, so no problem. But steps should be very clear how we are applying Biot-Savart law in this case of finite wire. Okay, now once you got this formula of finite wire, you can extend it to various other cases which will include infinite wire, semi-infinite wire. Let's simply see how we can apply. So first example is infinite. Extension of this formula we are doing. So if you take the wire is infinite, so if you talk about perpendicular distance is d, and this end is going to infinite. So if you have to connect it from here, how will you move? You cannot move in this direction. Now you have to move, it is going higher, higher, higher. So you will keep on going higher, and at one point it will become like this. because we know that this is parallel, this will go to infinity. So lines, parallel lines will meet at infinity. So this should be parallel. So this alpha angle will become how much? 90 degree, and similarly beta angle will also go to 90 degree. Okay, just a simple observation, and then in the formula you will put to get the result. So if alpha and beta both are 90 degrees, so magnetic field formula will become how much? Mu naught I upon 4 pi d in bracket sin alpha plus sin beta sin 90 plus sin 90 1 plus 1, sorry, it will become 2. Sin alpha 9, sin 91, sin 91 2, so there will be 2. So you will get the final formula of magnetic field due to infinite wire, बहुत बड़ा wire. It will become mu naught I over 4 pi d. Okay, again next application if we talk about, so next we can extend this formula for semi infinite wire, semi infinite wire. So semi infinite wire means, suppose that this is a wire, and this lower end goes to infinity, and here we are talking about magnetic field at this point. Okay, so magnetic field at this point, so distance is d. So here if you connect this point with the end point, no angle will be formed from this line. So alpha will become 0 degree, and other goes to infinite. So beta will become how much? 90 degrees. So alpha will be 0, beta will be 90 degree. So what will be the magnetic formula? Magnetic field will become mu naught I upon 4 pi d in bracket sin alpha plus sin beta, sin 0 1, sin 0 0, sin 90 1. So what formula will come? Mu naught I upon 4 pi d. That is a magnetic field due to semi infinite wire. Okay, one more case we can see here. We are talking about, let's say it's a finite wire only, but the point that we are considering here is in this direction, at this point, somewhere here. The wire is up to that limit only. So in this case what we are going to do now, these are the finite wires, finite ends. Wire is present, I current is going on, and the wire is present up to here only. So when you connect this end point, you will first see the perpendicular on the line of the wire. So this is perpendicular D. Now you will go in one direction, you will get alpha, and you connect this other line. Other line, for other line also you will go in the same direction, and you will get what? Beta. So you are going to get alpha as well as beta, both in the same direction. Okay, if you remember the derivation, both were in opposite direction, so we got a positive in between. So here alpha and beta both will be positive, so while putting the limit we will get a negative in between. So magnetic field will become mu naught I over 4 pi d bracket sin alpha minus sin beta. Now beta minus alpha or alpha minus beta, no confusion at all. You just have to write down the positive answer, and direction you can use by right hand thumb rule. So whatever is coming, if alpha is more, sin alpha minus beta, beta is more, sin beta minus alpha. So it means big minus is small, so that you get a magnitude positive. And direction you can easily calculate using dl vector cross r vector. So dl cross r vector, it will come inward, or right hand thumb rule also you can apply. So that will be the direction of magnetic field into the plane. Clear? Okay, so these are the important applications of finite wire, Biot-Savart law on a wire. Wire can be finite, so we derived the formula, and from that finite wire we can derive infinite wire, semi-infinite cases, and all those things. Okay, let's see one question quickly. Suppose we have a wire like this, I current is going on in this wire, and same I current is going on here, and at a coordinate we are talking about x comma y. Okay, at this point we need the magnetic field. So at this point if you need, so we have two wires, So direction first of all we will check. So both of them are giving in the outward direction dot. Okay, both wires are giving magnetic field outward direction dot. So we'll add both of them. So let's draw the perpendicular here. So x comma y, perpendicular distance to the y axis will be how much? X coordinate. And when you will connect this line, when you connect this line, let's say this angle is theta, other one will go to infinity because other end goes to infinite. Here also other end goes to infinite. So one end goes to infinity and one end is fixed. So one angle will be there theta, other angle will be 90 degree. So magnetic field formula will become how much? Magnetic field formula will become mu naught I upon 4 pi d in bracket, one angle is theta, so sin theta. So you can define sin theta in this triangle. This is x and this one will be root over x square plus y square and this one will be y. So sin theta if you define it will become y upon root over x square plus y square. This is sin theta and plus another angle 90 degrees, so it will be 1. Okay. Now due to other wire, if you do again, it will come mu naught I upon 4 pi d. For other wire, if I talk about, this is the perpendicular distance and that perpendicular distance will be y. So sine, if you define sine of the angle here, let's say it is theta or alpha. So if you define sine alpha, it will become how much? X upon root over x square plus y square. And other angle will go, other is going to infinity, other end is going to infinity. So when you will connect it, you will have to move parallel, that is 90 degree. That will become 1. And after simplification, this will be your answer. Okay, thank you very much.